Question 1. Let Sn denote the sum of first n terms and n terms of an AP if S of 2n is equal to 3Sn. Then the ratio of S3n upon Sn is equal to, we have four options, A4, B6, C8 and D10. So we have S of 2n is equal to 3 of Sn. So we're gonna solve this. We get as 2n upon 2, 2a plus of 2n minus 1 of d equal to 3n upon 2, 2a plus of n minus 1 t. So we get as 2a n plus 1 of d. Therefore, S of 3n upon S of n can be written as 3n upon 2, 2a plus of 3n minus of 1 of d upon n by 2, 2a plus n minus 1 of d. We solve this, we get 6. Therefore, option B is the correct answer. Question 2. If the numbers A, B, C, D, E form an AP, then the value of A minus 4B plus 6C minus 4D plus E is, we have four options, A1, B2, C0, D minus 1. If D is a common difference of the AP, therefore we have B, the common difference, A, B, C, D and E, then B is equal to A plus D and C is equal to A plus 2D, where D is equal to A plus 3D and E is equal to A plus 4D. So we solve this as A minus of 4B plus of 6C of 4D plus of E, which we have the condition for this. So we substitute the values. So we get as A minus of 4, A plus D plus of 6, A plus 2D minus of 4, A plus 3D plus of A plus 4D equal to 0. So here A is equal to S1, which is equal to 6. So for S1 will be equal to the sum ends over here. When we solve this, we get equal to 0, which is our option C. Therefore, option C is a correct answer. Question 3. Find sum of 3-digit numbers which are divisible by 7. The smallest 3-digit number divisible by 7 is 105. That is the smallest, and the greatest is 994. Given sequence is an AP with difference is equal to 7. Therefore, 994 is equal to 105 plus of n minus 1 of 7, which we use the general term of formula, that is Tn is equal to A plus bracket n minus 1 into D. Therefore, we solve this, we get n is equal to 128. Therefore, we use sum formula, that is n upon 2, 2a plus of n minus 1 d. We substitute the value, we get 128 by 2, 105 plus of 128 minus of 1, 7. We solve this, we get 70336, which is our option C. Therefore, option C is the correct answer. Question 4. The sum of first n terms of an AP whose last term is L and the common difference is D is, we have four options. We have L is equal to A plus of n minus 1 D for the last term, and for sum, that is n by 2 A plus L. eliminating A, we get, let this be equation number 2 and this be equation number 1. So eliminating A, we get Sn is equal to n by 2 L minus of n minus 1 D plus of L. We solve this further, we get n by 2 2L minus of n minus 1 D, which is option B. Therefore option B is the correct answer. Question 5. A student read common difference of an AP as -2 instead of 2 and got the sum of first 5 term as -5. Actual sum of first 5 term is, we have 4 options, A 25, B -25, C -35 and D 35. We have D is equal to -2 and the sum given as is equal to -5. So therefore we have formula for sum, that is Sn is equal to n by 2 2 of A, n minus 1 of D. We substitute the value, we get as -5 equal to 5 by 2 2A plus of 4 minus of 2. We solve this, we get A is equal to 3. Hence the actual sum where D is equal to 2 is 5 by 2 2 into 3 plus 5 minus 1 2. We get this as 5 by 2 6 plus 8 equal to 35, which is our option D. Therefore option D is the correct answer. Question 6. If angles of quadrilateral are an AP whose common difference is 10 degree, then the angles of quadrilateral are, we have given options in degree. Suppose that angle A is equal to x degree, then angle B will be x plus of 10 degree. Same for angle C will be x plus of 20 degree, and for angle D x plus of 30 degree. So we know that angle A plus angle B plus angle C plus angle D is equal to 2 pi. Putting this value, we get x degree plus of x plus 10 plus of x plus 20 plus of x plus 30, which is equal to 360. We solve this for x, we get x is equal to 75. We substitute the value of x in every A, B, C and D, which we get as A as 75, B as 85, C as 95 and angle D as 105, which is our option B. Therefore option B is the correct answer. Question 7. If the ratio of the sum of n terms of two APs be 7n plus 1 is to 4n plus of 27, the ratio of the 11th term will be, we have 4 options, A 2 is to 3, B 3 is to 4, C 4 is to 3 and D 5 is to 6. Let Sn and S dash n be the sum of n terms of two APs, and T11 that is 11 and T dash 1 that is 11 be the respective 11th terms. Then Sn on S dash n is equal to n by 2 2a plus n minus 1 of D upon n by 2 2a dash plus n minus 1 of T dash, which is equal to 7n plus of n upon 4n plus of 27. We solve this, we get A n minus 1 upon 2 d a dash n minus 1 upon 2 d dash, which is equal to 7n plus of 1 upon 4n plus of 27. So now we put n is equal to 21, we get a plus of 10d upon a dash of 10d dash equal to t11 upon t dash 11, which is equal to 148 upon 111, which is equal to 4 upon 3, which is our option C, that is 4:3. Therefore option C is the correct answer. Question 8. The number of numbers between 105 and 1000 which are divisible by 7 is, we have given as 4 options, that is A 142, B 128, C 127 and D 126. Required numbers, n is the number of terms in series, that is 105 plus of 112 plus 119 plus of 994. So let 994 equal to the nth term of above AP. So 994 is equal to 105 plus of n minus 1 into 7. We solve for n, we get n is equal to 994 minus of 98 upon 7, which is equal to n is equal to 128, which is our option B. Therefore option B is the correct answer. Question 9. If log to the base 9 of 3 raised to 1 minus x plus 2 log to the base 3 4 into 3 raised to x minus 1 are in AP, then x is equal to, we have 4 options. The given numbers are in AP, that is 2 log to the base 9 3 raised to 1 minus x plus of 2 equal to log to the base 3 4 x minus of 1 plus of 1. So we solve this, we can write as log 3 log to the base 3 raised to 2 3 raised to minus of x plus of 2 equal to log to the base 3 4 3 raised to x minus of 1 plus of log to the base 3 of 3. So we can write this as 2 by 2 log to the base 3 3 raised to minus 1 minus x plus of 2 equal to log to the base 3 3 of 4 3 raised to x minus of 1. So we can write it as 3 raised to minus 1 minus x plus of 2 equal to 3 of 4 3 raised to x minus of 1. Write this as 3 by y plus of 2 equal to 12y minus of 3, where we take y is equal to 3 raised to x. We solve this, further we get 12y square minus of 5y minus of 3 equal to 0, which we get for y we get as 1 minus by 3 or 3 by 4. We again resubstitute the value of y, we get 3 raised to x is equal to minus of 1 by 3 or 3 raised to x equal to 3 by 4, which is x equal to log to the base 3 of 3 by 4, which is x is equal to 1 minus log to the base 3 of 4, which is our option B. Therefore option B is the correct answer. Question 10. If sum of n terms of an AP is 2 into n square plus 5n, then the n term will be, we have 4 options, that is 4n plus 3, B 4n plus 5, C 4n plus 6 and D 4n plus 7. As we know that T of n is equal to S of n minus of S of minus n, so we can substitute that, we can write 2n square plus of 5n minus of 2n minus 1 the whole square plus 5 of n minus 1 bracket. We solve this, we get 2n square plus of 5n minus 2n square plus of 4n minus of 2 minus 5n plus of 5. We further solve this, we get 4n plus of 3, which is our option A. Therefore, option A is the correct answer. Question 11. After inserting n AMs between 2 and 38, the sum of the resulting progression is 200. The value of n is, we have four options, A 10, B 8, C 9 and D 7. The resulting progression will have n plus 2 terms with 2 as first term and 38 as the last term. Therefore, the sum of progression can be written as n plus 2 upon 2 plus 38, which is equal to 20 of n plus 2. By hypothesis, we can write this as 20 n plus 2 equal to 200, which we further solve, we get n is equal to 8, which is our option B. Therefore, option B is the correct answer. Question 12. If log 2 log and log bracket 2 raised to n minus 1 and log bracket 2 raised to n plus 3 are in AP, then n is equal to, we have four options. As we have log 2 of comma log 2 raised to n 1, that is minus 1, and log bracket 2 raised to n plus of 3 are in AP. Therefore, we can write this as 2 of log 2 raised to n minus of 1 equal to log of 2 plus log of 2 raised to n plus of 3. Further solving this, we get 2 raised to 2n minus of 4 into 2 raised to n minus 5 equal to 0. We solve this, we get 2 raised to n minus of 5, 2 raised to n plus of 1 equal to 0. So 2 raised to n cannot be negative, hence we take 2 raised to n minus of 5 equal to 0. Therefore, we get 2 raised to n equal to 5, that is n is equal to log to the base 2 of 5, which is our option B. Therefore, option B is the correct answer. Question 13. If the sum of three numbers of arithmetic sequence is 15 and the sum of their sequence is 83, then the numbers are, we have given options in sequence. So we let three numbers be a minus d, a and a plus d. For the first condition, we have a minus d plus of a plus d equal to 15. Further solving this, we get a is equal to 15. For the second condition, we have a minus of d the whole square plus of a square plus of a plus d the whole square, which is equal to 83. We solve this, we get a square plus d square minus of 2ad plus of a square plus d square 2ad equal to 83. Further solving this, we get 2 of a square plus d square plus a square is equal to 83. Putting the value, that is substituting the value a is equal to 5 in this equation, we get 2d square is equal to, that is 2 of 25 plus of d square plus of 25 equal to 83. For the solving, we get 2d square of 8, which is d is equal to 2. Therefore, the numbers are 2, that is 3, 5, 7, which is our option B. Therefore, option B is the correct answer. Question 14. The sum of first 10 terms of series root 2 plus root 6 plus root 18 plus is, we have four options. Given series is a GP with a is equal to root 2 and r is equal to root 3. So we have for s of 10, we have root 2 of root 3 of 10 minus of 1 upon root 3 minus 1, which is S of n is equal to a of r raised to n minus of 1 upon r minus of 1. We solve this, we get this as root 2, 243 minus of 1 upon root 3 minus of 1 into, we rationalize the denominator and numerator, we get root 3 plus of 1 upon root 3 plus of 1. Further solve this, we get 121 root 6 plus of 121 of root 2. Taking 121 as common, we get 121 root 6 plus of root 2, which is our option A. Therefore, option A is the correct answer. Question 15. For a GP whose fourth term is 24 and ninth term is 76, R and S10 is equal to, we have given 4 options. We have the fourth term given as 24 and the ninth term given as 768. So for T4 we can write it as AR cube, and for where substituting the value of T4 we get AR cube is equal to 24, and for T9 we have AR8, which is AR8 is equal to 768. Solving, we get A is equal to 3 and R is equal to 2, which is greater than 1. Therefore, S of 10 is equal to, we have A of R raised to 10 minus of 1 upon R minus of 1. Substituting the value, we get 2 raised to 10 minus of 1 upon 2 minus of 1, which is equal to 3 bracket 2 raised to 10 minus of 1, which is our option B. Therefore, option B is the correct answer. Question 16. The product of first 3 terms of a GP is 1000. If 6 is added to its second term and 7 is added to its third term, the terms become in AB. Find the GP. We have 4 options which is given in sequences. Let the term of given GP be A by R, A and A into R. The product of this, the condition, we have A by R into A into AR is equal to 1000, where A by R comma A plus 6 comma AR plus 7 are in AP. Therefore, we solve this, we get 2A plus of 6 equal to A by R plus A by R plus of 7. Solving further, we get 25 is equal to 10 by R plus 10 into R. We make some adjustment, we get 2R square minus of 5R plus of 2 equal to 0. Solving this further, we get 2R minus of 1, R minus of 2 equal to 0. Therefore, we get R is equal to 2 comma half. So therefore, as the GP is 5, 10, 20, or it can be 20, 10 and 5, which is our option matches with 5, 10 and 20, that is A. Therefore, A is a correct answer. Question 17. 2.345 NP by Q form is, we have 4 options. We can write 2.3.45 bar is equal to 2.3 plus of 0.045 plus of 0.00045. Continue, which can be written as 23 by 10 plus of 45 by 1000 plus 45 by 10,000. So for the second term onwards, the term are in GP. Therefore, that is S of infinity can be written as 1 A upon 1 minus R. That is 45 by 1000 upon 1 minus 1 by 100, which is equal to 1 by 22. Further solving this, we get, that is for infinity we can substitute the value, that is 2.345 bar, which is equal to 23 by 10 plus 1 by 22. Solving this, we get as 129 by 55, which is our option A. Therefore, option A is the correct answer. Question 18. If x is equal to summation of n is equal to 0 to infinity of a raised to n, where y is equal to summation of n is equal to 0 to infinity b raised to n, z is equal to summation of n is equal to 0 to infinity, which is ab into ab raised to n, where ab is less than 1, then we have four options that is given x, y, z. So we have x is equal to summation of n is equal to 0 to infinity a raised to n, which can be written as 1 upon 1 minus a, where a can be written as x minus of x. For y is equal to summation of n is equal to 0 infinity b raised to n, can be written as 1 upon 1 minus b, which is b is equal to y of minus 1 upon y. And we have z equal to summation of n is equal to 0 to infinity a n and b raised to n, which can be written as 1 upon 1 minus ab, can be further written as ab is equal to z minus of 1 upon z. So for x minus 1, x into y minus 1 upon y is equal to z minus 1 upon z. For the solving this, we get as xy plus z equal to zx plus yz. So we compare our answer with the options. So the option B matches, that is x plus y plus z, x plus y plus z, xz, zx plus yz. Therefore option B is the correct answer. Question 19. If sum of n terms of a GP is 255 and n term is 128 and common ratio is 2, then first term will be, we have four options, A1, B3, C7 and D2. Given that A of r raised to n minus of 1, r minus 1, that is infinity, sum of infinity is equal to 255, where r is equal to, that is greater than 1. Therefore we can write this as r raised to n minus 1 equal to 128. Let this be equation number 2 and this be equation number 1. And the common ratio given as 2. Therefore we get a 2 raised to n minus 1 equal to 128. Let this be equation number 4. Let this be equation 3. And we get a raised to 2 raised to n minus of 1 upon 2 minus 1, which is equal to 255. Let this be equation 5. Dividing 5 by 6. Dividing 5 by 6. Sorry, that is 5 by 4. Please note that it is 5 by 4. So we get 2 raised to n minus of 1 upon 2 raised to n minus 1 equal to 255 by 128. We take 2 minus of 2 n plus of 1 minus of n plus of 1 equal to 255 upon 128. For the solving this, we get 2 raised to minus n equal to 2 raised to minus 8. If we compare this, we get n is equal to 8. Therefore putting n is equal to 8 in equation number 4, we get as 2 raised to 7 equal to 128, which is 2 raised to 7, or a equal to 1, which is our option, that is a into 2 raised to 7, please know that, and equal to 128. So we get a is equal to 1. Therefore our option A is the correct answer. Question 20. The first term of GP is 7, the last term is 448, and the sum of all the terms is 489. sorry, it is 889. Then the common ratio is, we have h is equal to 2ab upon a plus b, which we can write it as, sorry, it is for GP, so we don't use this formula. We know that we have a is equal to 7 and a r n minus of 1 is equal to 448. So for now Sn, we have a into r is to n minus of 1 upon r minus of 1, which is equal to 889. Further solving this, we get a r raised to n minus 1 into r minus of a upon r minus of 1, which is equal to 889. We know that a into a raised to n minus 1 is equal to 448. We substitute that, so 448 into r minus of 1, 7 upon r minus 1 is equal to 889. Further solving this, for r we get r is equal to 2, which is our option D. Therefore option D is the correct answer. Question 21. If h is a harmonic mean between a and b, then 1 upon h minus a plus 1 upon h minus b is equal to, we have four options. We have h is equal to 2ab upon a plus b, which can be written as h minus of a equal to 2ab upon a plus of b minus of a, which can be written as ab minus of a square upon a plus of b. Further, we take subtract b, we have 2ab a plus b minus of b, which we get as ab minus of b square upon a plus of b. Adding both this, we get 1 upon h minus a plus 1 upon h minus b equal to a plus b upon ab minus of a square plus a plus b ab minus of b square equal to, we take a plus b. For the solving, we get b minus a, b minus a upon ab, which we cancel out this, we left with a plus b upon ab, which can be written as 1 upon a plus 1 upon b, which is our option B. Therefore option B is the correct answer. Question 22. If h is a harmonic mean between a and b, then h plus a upon h minus a plus h plus b upon h minus b is equal to, we have four options: a half, b minus half, c2 and d1. We can write h is equal to 2ab upon a plus b. Further, we can h upon a, that is we get as 2b upon a plus b. For h plus a upon h minus a, we get as 3b plus of a upon b minus of a. Similarly, for h plus b upon h minus of b, can be written as 3a plus of b upon a minus of b, which is equal to minus of 3a plus of b upon b minus of a. Further solving this, we add both of this, we get h plus of a upon h minus of a plus of h plus of b upon h minus of b equal to, can be written as 2b minus of 2a upon b minus of a, which is equal to 2, which is our option C. Therefore option C is the correct answer. Question 23. If the 7th term of harmonic progression is 8 and the 8th term is 7, then its 15th term is, 7th term we have four options, that is A, B, C and D. 7th term of corresponding AP is 1 by 8 and the 8th term is 1 by 7. So we have a plus of 6d, which is equal to 1 by 8, and a plus of 70, which is equal to 1 by 7. Solving this, we get d is equal to 1 by 56 and a is equal to 1 by 56. Therefore the 15th term of this AB we get as 1 by 56 plus 14 into 1 by 56, we get as 15 by 56. Hence the required 15 term of the HP is 56 by 15, which is our option D. Therefore option D is the correct answer. Question 24. Harmonic mean between two numbers is 4. Then arithmetic mean, that is A, and geometric mean, that is G, between them satisfies the relationship of 2A plus G square is equal to 27. Then the numbers are, we have 4 options. Let the numbers be A and B. Then 4A is equal to 2AP upon A plus B. We solve this further, we get as A plus B is equal to AB upon 2. For arithmetic mean, we have A plus B upon 2, and for geometric mean, we have root of AB. This is for the harmonic mean. So also we have an equation given as 2A plus of G square is equal to 27. We substitute of A and G, we get A plus B plus of AB equal to 27. Further solving this, we get AB upon 2 plus of AB equal to 27. Therefore we get AB is equal to 80. Hence A plus B, that is when we get this option, that is AB is equal to 18, we can substitute in harmonic mean, that is we get A plus B is equal to 18 by 2, which we get as 9. Therefore A plus B equal to 9 only is our answer, which satisfies A, the condition, that is 6 and 3. Therefore option A is the correct answer. Question 25. If harmonic progression P term is Q and the Q term is P, then the PQ term is, we have given 4 options: A0, B1, CPQ and DPQ bracket P plus Q. Let A be the first term and D be the common difference of the corresponding AP. That is, for P term of AP plus DP can be written as A plus of P minus 1 D, that is 1 by Q. And for the Q term of AP PQ, that is A plus of Q minus of 1 D converted as 1 by P. Let this be equation number 2 and this be equation number 1. So from 1 and 2, P can write as P minus of Q of D equal to 1 upon Q minus of 1 of P, 1 upon P, that is equal to P minus of Q upon PQ. So we get D is equal to 1 by PQ. From 1, we substitute, we get A plus P minus 1 upon PQ. For the solving, that is equal to 1 by Q. We get A is equal to 1 by PQ. Now for the PQ term, we can write A plus of PQ minus of 1 of D. Substituting the value of A and D, we get as 1 upon PQ plus of PQ minus of 1, that is 1 upon PQ. Solving this, we get answer as 1, which is our option B. Therefore option B is the correct answer. So the PQ term is 1. Question 26. 1.3 plus of 5, 7 and 9, 11 plus up to n terms is equal to, we have given 4 options, that is in n. We have Sn, that is summation of r is equal to 1 to n, 4r minus of 3 and 4r minus of 1. We solve this bracket as r is equal to 1 to n. We get 16r cube minus of 16r plus of 3. Solving this further, that is we take summation inside, we get as 16 of r is equal to 1 2n r cube minus of 16 summation of r is equal to 1 2n r plus summation of r equal to n r equal to 1 2n 3. Further solving this, we get 16 n plus 1 n plus 2 upon 6 minus 16 of n plus 1 upon 2 minus plus of 3n. So in this further we get as n upon 16 n square minus of 7 upon 3, which is our option D. Option D is the correct answer. Question 27. If Sn, S1, S2 and S3 are the sum of the first n natural numbers, their squares and their cubes respectively, then S of 3 bracket 1 plus 8 S of 1 is equal to, we have given 4 options, that is A 9 S of 2, B 9 S of 1, C 9 S of 2 raised to cube, B D 9 into S of 2 raised to square. So we can write S1 is equal to n of n plus 1 upon 2, S2 is equal to n of n plus 1, 2n plus of 1 upon 6, S3 of n plus 1 upon 2, the whole square. So for S of 3, 1 plus 8 of S of 1, we substitute the value, we have n square, n plus 1 the whole square upon 4, 1 plus 8n, n plus 1 upon 2. For the sum of this, we get n into n plus of 1, 2n plus of n bracket upon 6, the whole square into 9. For the sum of this, we get as 9 s of 2, the whole square, which is our option D. Therefore, option D is the correct answer. Question 28. The sum of n terms of sequence whose r term is 1 plus 2 plus 3 to r upon r is, we have given 4 options. We have term of 1 plus 2 plus of 3 plus of r upon r, which can be written as r of r plus 1 upon 2 upon r, that is r plus 1 upon 2. So for sum, Sn is equal to summation of r is equal to 1 to n of t r. We have summation of r is equal to 1 to n r plus 1 upon 2, which is equal to 1 by 2. Summation of r is equal to 1 to n r plus summation of r equal to 1 to n of 1. Further solving this, we get half of n plus 1 by 2 plus of n. We get this as 1 by 4 n square plus 3n. Solving this further, we get as n plus of 3 by 4, which is our option D. Therefore, option D is the correct answer. Question 29. Sum of the square of first n natural numbers exceed the sum by 330, then n is equal to, we have 4 options, A3, B10, C15 and D20. So the summation of n square is equal to 330 plus of summation of n. You can write this as n upon n plus of 1 to n plus of n by 6 is equal to 330 plus of n of n plus 1 upon 2. Further solving this, we get n of n plus 1 to n plus 1 by 3 minus of 1, which is equal to 330. Solving this, that is n of n plus of 1 by 2 into 2 of n minus 1 by 3 is equal to 330. This is 330. Solving further, we get n of n plus 1 n minus of 1 equal to 990. Therefore we get n is equal to 10. which is our option B. Therefore option B is the correct answer. Question 30. 11 cube plus 12 cube plus 20 cube. We have four options, that is divisible by 3, is an odd integer divisible by 5, is an even integer which is not divisible by 5, is an odd integer which is not divisible by 5. So we have summation of n equal to 1 to summation of n equal to 1 to 10 n cube. We can write this as n of n plus 1 to the whole square, that is n is equal to 20, minus n of n plus of 1 upon 2, n is equal to 10 to 2. Further solving this, we get 20 into 21 upon 2 the whole square, minus 10 into 1 upon 2 the whole square. Further solving this, we get 44100 minus 3025. Further solving this, we get 4 we get 4105. If we see, this is an odd integer and it is divisible by 5, that is our option B. Option B is the correct answer, where it is an odd integer and divisible by 5. Therefore option B is the correct answer.